We were reviewing the problems from the outline last class. These. And we covered the first 5. So we'll cover these and then I'll see if you have any questions on the take-home portion. But we were on number 6, which is to find the expected value for number 48. Using this information, this is the rising global temperature. So the global temperature, it's saying, this one's saying it's dropped by 1.5 degrees Celsius. This is saying it's increased by 1.5 to 2. So this is less than 1.5, not dropped. This is 1.5 to 2, 2 to 3, and then greater than 3 degrees Celsius. And what the cost would be annually. This is the probability of each of those cases, which in most cases, the global temperature will not increase more than 1.5 degrees Celsius. To find the expected value, you take the weight or the cost, in this case, times its probability. Now, this is all in billions, so we could find it and then tag the billions on rather than putting it all those zeros in. That means we could take 90 times 50 written as a decimal, divided by 100.5, plus the next one, 180, times the decimal 0.15, plus 320, times a quarter, and the last one, 750, times 0.1. And that would be your expected value. So it's the weight or cost times its probabilities. So our expected value is 227 billion. After several years, because I mean, 1 year, you don't know which one it's going to land in, but after several years, if you average per year, it would be $227 billion. If you wanted to find out 10 years, then you'd multiply by 10. Any questions on that? So this is finding out after several years, you'll pay 227 billion per year. Any questions? Page 326, table 12. Won't let me type it. 326, table 12. It's back one. Must be 325. No. There it is. So it should be 324. This is breast cancer screening. This is your test, to test positive or negative, and going down is cancer or no cancer. If a person is chosen at random, find the probability they do not have cancer and had a positive test. So this would be the probability they do not have cancer. And positive test. So a person is chosen at random. That means we're using all 10,000 people. Find the probability they do not have cancer and tested positive. Tested positive is the first row. Do not have cancer would be right here, then the 694 out of all of them. Unless something is given like the next two, you always divide by the total. Given that a person does not have cancer, find the probability they tested positive. So test positive, given no cancer. Whichever part is given, you only use that row or column. So we were given there was no cancer. That means we're using this column. Testing positive is the 694. So it's 694 out of 9920. Any questions on that? So I used only that column because I was given the person did not have cancer. So I knew it had to come from this. And then positive is 694. Given a person tested positive. So now on this one, we're given they tested positive. Find the probability they do not have cancer. So on this one, we're given they tested positive. You're only using that row. So this top row. Because we know they tested positive. We want the probability they don't have cancer, then it's the 694 out of 766. When you're finding probabilities, it's up to you. Unless it specifies, you can use the fraction, the decimal, or the percent. If you're like the next part, we're asked for the sensitivity or the specificity. Those should be percents. Not should, they are percents. But probabilities, unless it specifies, you can leave the fraction. And you don't have to reduce. Any questions on that part? 7A, B, and C. Do you need to try more probabilities on these? Or are we good? Okay. Number 8. Find the sensitivity and the specificity and explain what they mean. Same problem. Sensitivity is this block right here. It's the probability that you test positive given you have cancer. What you're well, let's find the probability first, and then we'll explain it. Given cancer is this column. Testing positive then is 72 out of the 80. You want it written as a percent. So we need to divide and multiply by 100. So sensitivity is 90%. What that means is if you have cancer and you go to take the test, 90% of the time it will be accurate. You will test positive. So there's a 10% chance that if you have cancer, the test could tell you you don't. So sensitivity, 90%. Specificity is the probability you don't have cancer and the test is negative. So you're seeing how accurate it is when you go in. If you don't have cancer, it should test negative. We're given that you don't have cancer. That's the given part. This column. Probability of testing negative is this bottom one, 9,226. divided by 99.20. And we want to multiply it by 100 so we can make it a percent. So the specificity is even stronger. It's 93%. That means if you don't have cancer, the test is correct 93% of the time. So 7% will be told they have cancer even though they don't. Any questions on that? That is everything that's on the in class. There's just those 8 problems. The take-home portion, there's 5 questions. Was there any questions on any of them? Number 5. A professor feels that 25% of her 200 students are cheating. She has all students take a lie detector test to see who is cheating. The true positive is 88%, true negative is 92%. Now, when you're talking about true positives and negatives, remember, as long as your test is going across, use their words. Positives go across the top, negatives go across the bottom. If you test positive and you cheat, the test was correct, so it's a true positive. This one also a positive. You're testing positive that you cheated, but you didn't, so this is false. So the positives go across and the negatives. You tested negative, but you cheat. Well, then that would be wrong, so it would be false. You tested negative and you don't cheat, which would be correct. That's a true. As long as your tests are going across those places, they always land there. This is always the true positive and the false positive. This is always false negative and true negative. We're told 200 students. That's our total. %25 of our 200 students are cheating. Answer the questions that follow, assuming the teacher is correct. So we're assuming 25% cheat. That should get you this bottom row. How do we find 25% of the 200 students? Anyone? Of means multiply. So 25% of 200. How many students are cheating? Anyone? Yes, 50. If 50 are cheating, how many are not cheating? This needs to add up to 200. So if we take the 200 minus the 50, 150 are not cheating. Now, when you're given the true positive, false positive, any one of these, the probability or the percent you're given is from the denominator or the bottom value, because like the true positive, that is given they're cheating, what's the probability of testing positive? So it's using the 50. As long as your test always goes across, you will always use the number below it. So true positive is in this first corner, and it says 88%. A true positive 88% of the time. Now that 88% is if you're cheating, there's an 88% chance that the test will test positive. So it's out of the cheaters. 88% of the 50. I'm getting 44. How many then will be right below the 44? Mm-hmm. 50 minus 44 is 6. 44 and 6 give us our total of 50. True negative. True negative is here. You tested negative and it was correct 92% of the time. What a true negative means is you don't cheat. What's the probability it's correct? That means you're only using the people who are not cheating. So it's 92% of the 150. 138. And then finding the last one on the top. Yep, 12. 138 gives us 150, and then you just need to add across. Adding across 56, 140, adding down 200. Any questions on filling it out? Yeah, I think we haven't done a lot of these, and that's why I wanted to help you, and that's why I put it on here. The one on the in-person will already be set up, like the last problem we did. Now it says the teacher decides to give an F to all the students the lie detector tests positive. So testing positive, all of these students, 44, 12, 56 of them. So if you tested positive, you're getting an F. Explain how the students with a false positive must feel and the students with a false negative. So a false positive is right here. They don't cheat, but tested positive. Include the number of students. So the false positive is 12 students. False positive, what was the other one? True, false negative here. False negative was 6 students. And you just want to write a little paragraph about how those students would feel. So false positive is here. That means they tested positive, but they don't cheat. So you want to talk about how those people would feel. So those 12 students are getting an F, even though they didn't cheat. These 6 students cheat, but the test said they don't. So they got away with it. And so write a paragraph, a few sentences about how each of those would feel, and make sure you include how many students are in that group. Any questions on that? Is everyone all right writing it? Well, not everyone, the 2 of you. Good. Any other ones? On this one here, risk aversion, I just want you to read about it and think about it and write a little paragraph. But in the book, it's 311 to 313. 311 has most of it, but then you could just look up an article also and discuss from the article. It's up to you. But that's on page 311. Any other ones? Number 2. You roll 2 fair die and write down the 2 scores that you obtain. Then you toss a fair coin and determine how to combine the scores. If the coin lands heads, you add. If the 2 scores land tails, you multiply. Write the sample space. So the sample space should be, no, I guess it won't be because you're adding. Roll 2 fair die and write down 2 squares. I'm going to write them all first, just the 2 die. You can get a 1 and a 1, 1 and a 2. And then a 2 with each of them. A 3. I got this from the book and I thought it looked interesting. But I know it's one that's going to take a little more time. So we roll 2 die. There's our possibilities of our 2 die. Then we toss a fair coin, head or tail. If the coin lands heads, you add them. Tails, multiply. What is the probability? Okay, so for our outcome though, like we can have a heads and all of these values, but they really only want what the value is going to be. So when we're doing a heads, you multiply all these values. Sorry, you add. So you could have a heads and a 2, a heads and a 3, heads and a 4, head 5, head 6. Well, you don't need the head part. So if we get a heads, we add them together. If you add all of these, they're going to start repeating. Whoops, so we wouldn't have a 1 though. I was doing the multiply one. We'd have a 2, a 3, a 4, 5, 6, 7, all the way to 12. Some of them would repeat. Now multiplying, we'd have a 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 12. So we have all those. 3, 6, 9, 12, 15, and 18. I'm going to leave some spaces so we can have them in order. Then go to the 4s. A 4 we have, 8, 12, 16 we don't have. 20 and 24. Multiplying 5, we have 10, 15, 20, 25, 30. 6, 12, 18, 24, 30, and 36. This down some. So those are all the possible outcomes. Any questions on that? So these would be your sample space. We would roll 2 die and toss a coin. If it's heads, we add whatever we rolled. If it's tails, we multiply. Any questions? To find the total outcomes, you want to take each thing that you're doing and multiply its probabilities together. We're tossing a coin, that's 6 possibilities. We're tossing a second coin, and then, sorry, a die. The 2 dies are 6 each, the coin is 2. So you roll the first die, 6 possibilities, the second one 6, and then tossing the coin. These are all independent events, so you can multiply together and get total probability. 6 times 6 times 2, 72. So even though we've only listed 1, 2, 4, 13, 14, 20 here, some of them repeat. There's actually 72 possible outcomes. We need to find out how many times you can come up with a 9. How many different ways is there a 9? So check the adding ones and then check the multiplying ones and see when you get a 9. Adding to get a 9, this is a 7, so it's not there. 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. Here's a 9. Adding. So a head, a 3, and a 6 will give us a 9. 5, 6, 7, 8. Here's a 9. And a 9. And a 9. So when adding, there's 4 of them. Multiplying to get 9, there's only one way. Because we don't have a 9 and a 1, the only way is the 3 and the 3 with a tail. So if you can visualize your sample space, then it's one way of finding it. This is the actual sample space because we just want the numbers at the end. The reason I knew that was because it said the probability that you have a 9. So this is my sample space. But the total number of outcomes are all your possibilities. You roll a 6, and a 2. Total 72, we said 1, 2, 3, 4, 5. Probability of a 9 is 5 over 72. I knew it would be a little trickier one. That's why I wanted to do it for you or with you. But I did want you to see something a little more complicated. Any questions on it though? You're welcome. I think those 2 were probably the 2 hardest. Any other ones? What time is it? Oh yeah, we have time for one more. The first one. No. Only because I just realized they're not in order. They need to be put in order. I can't believe I did that. See something. We might be able to put it into Desmos and get it in order. So the under exams and final is where the take home is. That's where you'll submit it. The in-person is here. You need the password. I think we can highlight the data and put it into a list. So Control C, and then L equals that was not right. A piecewise. I don't know what I would need. Piecewise. Oh, it's square brackets. That's why. There we go. 35 elements. So you can highlight these because they're by commas and it'll put them into a list. And then what do we need? Mean, mode, and range. And there's your mean. I don't know if it'll organize them for you. Mode, you'll have to look through and see which one they don't do mode. So for mode, it's whichever one would repeat most often. So you would just look through and see, like there's a 10, 2, 6. But for mode, go through and see which one repeats the most. I think it might be that one. Did anyone see one repeat more? I think it's 10, 26. I think it's the only one that repeats. That would. So mean, mode, range. How do you find the range? Anyone? Largest minus smallest. So you find the largest and subtract the smallest. Did anyone find it? What was that? 10.1. Any questions on mean, mode, or range? 5-number summary. Smallest, lower quartile, median, upper quartile, and largest. You draw a box plot by drawing those 5. If we go back over here, well, smallest and largest, you will find here. You'll just put them there. Median's right here. Quartile. Oops, I must have been on the top part. When you're doing the quartile, you have to tell it which one you want. So you want L, I think it's colon. Nope. Oh, you just put the number. I thought you needed a colon. So whenever you're unsure of how to plug something in, just look it up. Nope, that didn't work. Hmm. 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 I'll have to look it up and see. But that's a large number of items. I don't expect you to put them all in order and do it by hand. but we'll continue on this one. But find the 5-number summary. Google how to do it with a list. The other thing you could do is highlight and put that in there, but and then try these. The interquartile range is just QU minus QL. And we'll go over more of this next class. I think those are the only ones that are tough. The rest, oh, we did almost all of them. Okay, so try the other ones for tomorrow and I'll answer any questions and go from there. Have a nice day.